Over the next few minutes, we will discuss principles for choosing the best regression model. What constitutes the best regression model depends on the situation. Best models should strive to have relatively few predictors to keep the model simple, a relatively high R-square, a relatively small standard error, relatively small p-values for the F and T test statistics, no cases with extraordinarily high leverage, no cases with extraordinarily large residuals and studentized residuals that appear to be nearly normal, predictors reliably measured and relatively unrelated, and predictors that are easy to measure. Generally, there are two reasons for building regression models. If our primary goal is to understand relationships among variables, aim for simple models with unrelated predictors and large test statistics, which will in turn give small p-values. If, on the other hand, your main purpose is to predict the value of a response from predictor variables, aim for large R-squared values and do not worry about collinearity. There are several automated systems for searching out best models once a single criterion is selected for optimization, including best subsets regression and stepwise regression. These methods do not check the assumptions and conditions and are vulnerable to other complications, so human oversight and analysis is still necessary to guard against misleading results. With best subsets regression, we begin by choosing a single criterion of best. For example, we might decide that the best model will be the one with the highest R-square value. Next, we choose a modest set of potential predictors. The third step is where the automation begins. A computer searches all possible models from your modest set of potential predictors and reports the best 2-predictor model, the best 3-predictor model, the best 4-predictor model, and so on. Of course, the technique becomes increasingly impractical as the size of the data set increases. In stepwise regression, the regression builds the model stepwise from a given initial model. At each step, a predictor is either added or removed from the model. The predictor added is the one whose addition increases the adjusted R-square the most. The predictor removed is the one whose removal reduces the adjusted R-square the least. Regardless of how you choose to build your model, data accuracy and completeness is essential to a good model. Checking the data for accuracy, missing values, consistency, and reasonableness can be a major part of the effort. It is not the most glamorous part of the job, but it is extremely important. Remember that automated systems do not check assumptions and conditions, so human intelligence must always be inserted into the process.